Hey guys, Henrik Scholder here with Mechanix Menace. Today I thought I should talk a little bit about what I have been spending a lot of time on this fall. I have been working on the suspension geometry for the car, and the main focus was to come up with a front suspension geometry that would work well together with the rear suspension geometry. Since I have decided that in order to save time and not mess things up too much, I would keep the stock suspension geometry for the rear suspension, which comes from a BMW E39. And the E39s are famous for having really good suspension geometry. They have good handling, road holding, and they are easy to drive. For instance, the M5 E39, many people think that that is actually still the best M5 from a driver's perspective. So that's really good. It's a multi-link suspension. A lot of modern suspensions are modeled after the BMW multi-link suspension. It's called Integral Lenker. Yeah, it's pretty good. Everything is aluminum. It's really lightweight as well. So at least to start, my plans are to keep that suspension geometry. What I have done is I have put that suspension geometry into this suspension geometry program. You can see an animation going on here. And basically the only thing I changed from stock was that I changed the height of the subframe to get the roll center height that I wanted and the camber gain. So the entire subframe sits a little bit lower than stock, not by too much, because then you mess things up. And then, since I'm going to use Corvette C7 suspension parts, except for the lower A-arms, which are C6, because the C7s, they were back ordered for like two and a half years. When they finally arrived again, the price had gone up from, I think it was like less than $200 to over $540. So the C6 lower A-arms have the same geometry. Actually, they look nicer. They are forged and kind of have a slim design. The C7s are cast, a hollow casting, which I guess is for stiffness, probably mostly for the anti-roll bar link attachment, and possibly for the shock absorber attachment, but otherwise same geometry. So suspension parts for the front suspension, C7 upper A-arm, spindle, the bearing units, which are the Z06 high performance ones, and then C6 lower A-arm. So the intention was to, like I said, come up with a geometry that would work well with the rear suspension geometry. And in order to do that, I have put a lot of hours into kind of researching how to go about this. And I have done a lot of reading. I mean, I have a lot of books on suspension geometry and vehicle dynamics in general, so I had read those again. And I have Googled many hours. I have also looked at applications from work, since I am a shock absorber design engineer and used to be partly at least a test driver as well. I have looked at some applications I have been involved with at work. Some of them I had the suspension geometry, so I could put that into this software as well and look how they were regarding roll axle, camber gain, bump steer, basically everything, caster, camber, of course. And what I ended up with is my goal was to have a camber gain for the front suspension, which is around 90% of the camber gain for the rear suspension. It seems like a lot of road cars, they have like 80% camber gain front versus rear suspension to have a car that is understeering at the limit. Race cars sometimes have the same camber game front and rear, and then they can get a little bit tricky and snappy. So my thought was that, okay, I'll go with 90%, which should give you better road holding, better turn in, still slight understeer, but maybe you can't let your granny drive the car, which I won't do anyways, because I don't have one. And also, I will show you later, the front suspension geometry will be adjustable. I have made the attachment points for the A-arms adjustable, so I can adjust roll center height, I can adjust camber, I can adjust camber gain, I can adjust caster, so basically everything except for track width. And I mean, why would you need to do that? So yeah, this is my personal home computer, and I have been sitting here doing the geometry in the suspension program, and then downstairs in my kitchen I have my work computer for when I'm working from home, and I'm using the CAD system from work, so all the CAD stuff is done on that computer. So I have been kind of going back and forth between the two computers, and yeah, let me show you a little bit about the suspension software here, and what you can find out, and what I ended up with after many hours of work and many iterations as well. Okay, let's have a look. So this is the Lotus suspension analysis software, and this is my rear suspension. I have scanned the entire suspension, and then I took out all the joints in the CAD system, and after that I have input all that data into this software, and here you can see an animation of heave movement, and then we have the front axle, and you can also have a look at both axles at the same time. So you can see a lot of lines and stuff, so you get the instant centers and the roll center, the roll axis and everything, and you can look at it like front view like here, or you can have a look in a side view. So here you have the side view instant centers. You can see how the roll axis is moving here, and also of course you can have a look from a top view. And what might be more interesting is if you go into roll. So here, a roll motion, you can see how the roll axis is moving side to side, and it moves of course differently in the rear compared to the front. In the side view, not so much is going on in a roll motion, but in a front view you can have a look, and you can see also here, you see how the roll axis is moving, and the animation in itself doesn't really show you that much. What you do see, especially if you've tried a lot of different combinations, is that you don't have a lot of bump steer, and you can see that the rear and the front camber movement is fairly similar, which is what I am looking for. So after you have run the analysis, you get a result sheet that I have exported to Excel, where you have the front suspension here, rear suspension here, and here are all the pickup points for the front and for the rear. Then you have a lot of static results here, camber, toe, roll center, etc. And here you have a list of other parameters, wheel, rolling radius, wheelbase, things like that. And here you get to the results. Here is the bump analysis. Positive values is compression, and negative is rebound or bump and droop. And I have calculated the camber compensation in degrees and camber compensation in degrees per meter, which is a common value. And in this column I made the comparison between front and rear, the percentage like I talked about before, and I was shooting for 90% in the compression mode, which is what is interesting, and you can see that it varies from 85 to 96%. Also this degrees per meter, a lot of people think that a good camber compensation for a rear axle is around 25 degrees per meter, and for the front 20 degrees. I have made the front more similar to the rear, as I said. Here you have the roll analysis, which is actually more interesting, and then negative values are the outside tire, which is what you're looking for. And here you can see I have between 85 to 94% front camber compensation compared to rear. And after that I have plotted, well, I should say also roll center is of course important. The rear I decided on 90 millimeters, and then with some recommendations on how the roll axis should slope, I came up with like this 47 millimeters for the front. In the future I will try to find out the main inertial axis of the car. I have an Excel sheet with a lot of weights for different components and their position, and I'm going to expand that. The more parts I have and the more parts I have weighed, I will put them in, and hopefully at one point I will be able to find the inertial axis. And one idea that a lot of experts say is that you want to have the roll axis parallel to the main inertial axis. So I think hopefully this is close, and I will be able to tune that. So we'll see where we'll end up. And I have made a lot of graphs here, which is maybe an easier way to look at comparisons. Here is the bump situation. That's not super interesting. The roll is what you are basically looking at. So the front is the blue line and the red is the rear, and you have like camber toe, roll center in XYZ, half track change, wheelbase change, anti-dive, anti-squat, blah blah blah. And one thing that you can see is for the front here, you don't have as much camber compensation as you have in the rear, because when you go into when you go into positive camber, this is on the outside tire, you have a different slope. You don't compensate as much. If this graph would be perfectly horizontal, then you would have 100% camber compensation, and the more slope you have, the less camber compensation you have. And I wanted the front to have slightly less camber compensation, as I said before. So all of this of course had to be realized in the CAD model for attachment points, and to tune or to modify the tube frame so I get the attachment points in good places. So let's go down to my work computer in the kitchen and have a look at that. Okay, so now I am down in my kitchen where I have rigged up my job computer. The reason why I'm here is because I have modeled the car in the CAD system we have at work. So let's have a look at some interesting stuff here. So here you can see a model of the tube chassis. You can also see these pale blue parts, which are my composite panels for the cabin. I should say that in this model a lot of stuff is missing. Some stuff might be wrong, and there will be additions and changes, I'm sure, but at least you kind of get a general feel for what the chassis will look like. And in the rear here we have the BMW E39 5 Series suspension, which is sitting on this subframe here, which will be bolted to the chassis, as you can see, with 4 bolts here. We'll have a little look at that later on. And here is the front suspension based on the Corvette parts. In the rear, I'm going to have a pushrod suspension with horizontal shocks like this, but in the front I'm going to have a regular setup with shocks directly attached to the lower A-arm. And the shocks I am using are, of course, Öhlins shocks. These are called ILX, which is a shock that I have designed. They are used in lots of different applications, from high-end track day cars to like GT cars, and lots of different race categories. They are really versatile, and in my application here they will be 4-way adjustable, so you have low and high speed compression adjuster here, and then you have low and high speed rebound adjuster there. I will also have a lifter here, or an actuator pushing against the spring, which you cannot see, so I will be able to raise the suspension when I need to go over a speed bump or my super steep driveway down into the garage. Okay, let's start having a look at the rear suspension. It looks like this. This is the Integrallenker, and this little part here is this Integrallenker, the integral link. As you can see, it's a multi-link suspension, so you have this lower H-arm here, you have a camber arm and a toe arm, and this integral link is attached to the upright here. And by combining all of this stuff, you can basically tweak the camber curve and the toe curve independent of each other, and you have a lot of other benefits too regarding elastic kinematics and stuff, which I will not go into in detail here, or not at all actually. So this is what it looks like, and let's see if we can see what it looks like when moving. Let me do like this. Let's see, where do we have it? So hopefully I can move this. You can see how it moves. Of course, everything is not moving the way it should. Some links are twisting in a way they're not supposed to. You can see the the camber link is jumping between 2 positions. I don't know why, but you get the general idea of how it's moving. And for the front suspension, it looks like this, and let us do the same thing here. Okay, like this. So yeah, this will move something like this. I will keep the stock rubber bushings in the A-arms. The rear also has all the stock rubber bushings, and I think since I have kind of changed my mind, I'm not going full-on hardcore race car, legal race car anymore. I'm more kind of shooting for a car that is quick on track but still has decent comfort, so like high-end Porsche or something like that. But if need be, I can always swap out the rubber bushings for spherical bearings in the future if I feel so inclined. Okay, let's see what it looks like in the chassis. So I will hide some stuff here. Yes. So as I said before, I am shooting for lots of adjustability to be able to change the front suspension geometry, how it kind of works in conjunction with the rear suspension. Rear suspension is basically, of course I can adjust the toe and camber, but I cannot adjust ride height, camber gain, things like that. But in the front I can. So if you look here at the lower A-arm, you have these vertical holes here, so you can move this up and down, enabling roll center changes. And for the upper A-arm, I will have this attachment plate made, and if you look here, you can see that the plate itself has oval holes, horizontal oval holes, so that means that you can change the caster by moving it back and forth. And then you see there's a space here. I will have shims between this plate and the chassis, and also there will be these shims for the attachment to the bushings. So that means that I can change camber by having thicker or thinner shims either here or here. And also if I, well, actually let us do like this instead. If we open the chassis model separately, you can see there are lots of holes here. So these holes are spaced 6 millimeter apart vertically, and of course in order to have them that close, I needed to offset them like this. So you have each row here is you have 12 millimeter distance. So if I want to change it 6 millimeter in height, I have to use either this hole or that hole. But in conjunction with the horizontal adjustability of the upper A-arm attachment plate, I can get to the same position with 6 millimeter height increments. So that means I can also use this to both change the roll center and by changing the height of the attachment point for the lower and the upper A-arm, I can also change camber gain, which would be nice. And yeah, you can see the engine is kind of covered from the top by these two bars. So I will actually assemble the engine from below. The gearbox is not here now in this model. Maybe I can add it like that. So this, I need to take this bar out, so I will be able to raise it straight up into this hole, and then this will be covered with a big aluminum plate, which will be screwed down here to stiffen up the whole chassis. Yeah, I guess that is it. So thanks for watching. I hope you have found this interesting. And please, if you have any comments or questions, don't be afraid to ask them. Also, if you would like to like and share, that'll be great. And have a look out for the upcoming video, which I think will be out, I hope, before New Year's. And this time it's going to be a video from the garage. I have been doing some stuff there, which are, for me at least, a pretty big deal. I think you will find that one interesting as well. So have a look out for that one. And yeah, Merry Christmas. I guess that is already past. Maybe, I'm not sure when I'm going to post this. But otherwise, have a Happy New Year. Thank you. Bye.